Hi, today I want to talk a little bit about how to locate a image, right? And so I did show you this once before, but let's check it out one more time. This is what I'm going to be talking about, doing a mathematical example of this here. We see here that the pencil looks different when I put it in to the cup of water. Right? And what do we, there we go, that's pretty good. And what do we observe here? Well, it looks larger, and it actually looks a little bit closer, right? We see that it looks a little bit closer than the pencil out of the water. Again, the image is not located in the same place as the object is. So let's see if we can't do a little bit of what's called ray tracing to figure out how that works. So let's jump over and peek at the PowerPoint real quick. Here is a schematic of the situation I was just showing. We've got some object that is inside some medium, and this picture is drawn with n1 greater than n2. Now this equation works either way, but do notice that the object is located in n1. So that's how you can get this equation straight. The object is located in n1, and we have an observer out here located in n2. This equation then gives us a relationship between the object distance and the image distance. Notice here my object distance is labeled s, and in this case the object distance is the distance from the interface between the mediums. So we see here s is the object distance, the distance from the surface of the medium to the object, and s prime is the image distance from the surface to where the image is located. Remember, you've got an eyeball over here, so an observer over here, and the observer's brain thinks that light travels in a straight line. And so the observer's brain is going to say, oh, there's an object right here. This is where the observer is going to perceive the object being, we know that it is really right here. It's a fairly straightforward relationship. You do have to remember that the object is in n1, the observer is in n2. Okay, so let's apply this to an example. A fish in a flat-sided aquarium sees a can of fish food on the counter. To the fish's eye, the can looks to be 30 centimeters outside the aquarium. What is the actual distance between the can and the aquarium? Ignore the thin glass wall of the aquarium. Let's start by doing a quick picture and see whether we expect to get an object distance that is greater than or less than 30 centimeters. Here's my fish food, and here is my fish. Okay, so the way we want to do this is we want to draw some rays coming off of our can of fish food. Now, of the infinite number of rays that are leaving the can of fish food, I'm going to draw two. And those two are just going to help us understand what the situation is. So here's one ray. And here is another ray. Now, this is water, and this is air. So this is n equals 1. And in water, we have 1.33. So n equals 1.33, and n equals 1. We know that the rays bend towards the normal when they move from lower end to higher end. So it's going to look something like that, bends toward the normal. And let's draw our normal here. Again, the ray bends towards the normal. Okay, so the fish, its brain has evolved to know that light travels in a straight line. So where does the fish think the food is? The fish observes the food to be farther away than it really is. The food is really closer than it looks, which is why the fish is happy. He knows that. He's studied some optics. And at this point, we really can just now plug in our equation. So let's take a peek at what that equation looks like again. Our equation is s prime equals n2 over n1 times s. And they gave us s prime. We are looking for s. So we can do a little bit of algebra. So S prime times n1 over n2 equals S. Do notice that the object is in n1, and so in this case n1 is 1. And when we run our calculator, we get an answer of 22.6. So that confirms what our ray tracing said, right? Our ray tracing said we expect the image to be farther away than the object. And indeed, our math confirms that that is the case. We call this a virtual image because light is not actually leaving where the fish thinks the light is leaving.